This is lesson 2 of chapter 7, and in this lesson we'll practice what we talked about in the first lesson. In the first lesson we talked about writing ionic compounds. Ionic compounds, remember, are made between metals and nonmetals, and in this case the metal that we have is magnesium, the nonmetal that we have is chlorine. We want to write a compound based on these two elements. So the first thing to do is to figure out the charges that these would have, because if they're ionic, they have ions. They have charges. So you have to take a look at the periodic table for this, and if you take a look at the periodic table, magnesium is found in group 2, and group 2 has a +2 charge, which means magnesium is +2. Chlorine is found in group 17, they're the noble gases, so that's a -1 charge, so chlorine will have a -1 charge. So you have to know your charges on the periodic table. Feel free to just refer to the periodic table, and if you've written the charges above the groups, then use that. Now the rule that we said that we'll follow is you have to balance the charges. You have to have the same number of negatives as you have positives to make your compound. So in this case we have a +2, we have a -1. We have to have a -2 to balance this +2. The way we'll do this is we will add one more chlorine. And now, together, notice here, we have the required -2 to balance this +2. And this compound is formed from 1 magnesium and 2 chlorines. So we will write it as MgCl2. Here is the answer. Simple as that. You're essentially asking, well, how many of each of these do I need so their charges are balanced out? And that is the idea. All right, let's try the second one. This one says write the ionic compound formed between aluminum and oxygen. Again, we'll have to take a look at the periodic table for the charges of these two. And aluminum, if you take a look at the periodic table, has a +3 charge. Take a minute to verify. Nicely done. Oxygen, if you take a look, has a -2 charge. Now we have to do the same thing. The question is how many aluminums and how many oxygens must we put together so that they cancel each other out? Well, if I decide to add one more oxygen, then this gives me a -4. That doesn't really match the +3. All right, let's put down one more aluminum. Now I got a +6 and a -4. Wait a minute. How about one more oxygen? Now I've got a -6 on this side. I've got a +6 on this side. My charges match up. I've figured it out. I need 2 aluminums for 3 oxygens. So my answer will be Al2O3. Now what you've done here, this is a little tougher, but what you've done essentially is you have found the common multiple of these two numbers. Both of these two numbers multiply to 6. And they've taught you this method, or this, I guess, skill in math. And that's really what you're doing here. And you can do it by trial and error. You can add a bunch more of these and a bunch more of these as needed until you equal them out. With practice, this will actually become easier and easier. Why don't we try the third one here? This one actually uses a polyatomic ion. What I mean is this nitrate. So remember, we introduced polyatomic ions as common ions not found on the periodic table because they're made of more than one element. Nitrate, if you remember, if you take a look, has a charge of -1, and it's written as NO3. So it's NO3 -1. Ba is barium, and if you take a look at barium from the periodic table, you've got a +2 charge. So it is between Ba +2 and NO3 -1. Now NO3 is kept as a group. The whole group has a -1 charge. So the question is, how many of these NO3s do we need to balance each barium? Well, since it's a -1 charge, we need 2 of them. So we need 2 nitrates to balance each barium. And it's a 2-to-1 ratio. Now in this case, if we want to write down that we have 1 barium and 2 nitrates, if we put NO3 with a 2 at the end, if we write it like this, it looks like we have 32 oxygens, which is enormous. This is actually impossible. You cannot have this many oxygens on that little poor nitrogen. So what we'll have to do is we'll have to put parentheses around the nitrate to show that we have 2 nitrates. And in this case, you see you have 2 nitrogens, just like we have here. You have 2 times 3, 6 oxygens. 3 plus 3 is 6 oxygens. This is how you would write barium nitrate. So anytime you have a polyatomic ion, one of these, you'll use parentheses if, so use parentheses if you have more than one of them. You have more than one of them. That is when we'll use it. In fact, if you have only one, you do not need to use parentheses. What I mean here is, for example, pretend that we were putting lithium, which has a +1 charge, against nitrate, which has a -1 charge. Since they're both +1 and -1, you just need one of each. So you'll just write LiNO3. No need for parentheses. That's what we mean. Okay, why not you take a minute or a few minutes and try this on your own? So take a few minutes, pause the video, try to write these. Okay, and then the last one example that we'll do before we finish up the lesson will be doing the opposite. Here it says indicate the charge on each ion in the compound. So we're actually undoing it. We've been given the compound, and now we have to say which charges did these come from. And here's what we'll do. Now, in both of these cases, you'll find that we have chromium and copper. Both of these actually come from the D block. Remember, the special thing about the D block is that they can have more than one type of ion. So chromium, for example, can exist as a +3, as a +2, as a +1 maybe. Copper can exist as a +1, as a +2, maybe as a something else. So we have to, here's how we will figure out what the charge is. And the way we'll do it is we'll base it off of the anion, the negative, because chlorine can only come in one variety. It only comes as a -1. So the way we'll do this is we'll say we have 3 chlorines. So here they are, 3 chlorines. We'll write them out. And each chlorine, we know from the periodic table, has a -1 charge. This is simply looking at the periodic table and finding chlorine on it. Now, they are balanced by 1 chromium. So the big question is this: what must the charge of chromium be so that together it balances out all 3 of these chlorines? And obviously, it must be a +3 charge. And this is the answer. This is what you're supposed to do in this case. So really, the answer is chromium is a +3 charge, chlorine is a -1 charge. This is the answer. We've shown what these ions are if you break it apart. Let's try the second one. Here we have Cu2CO3. Now, you may recognize this one as being a polyatomic. In fact, you'd have to recognize it as being one of the 6 polyatomics we had you memorize. This is actually called carbonate. So, carbonate, if you take a look at the notes, previous lesson has a -2 charge. Now, balancing each carbonate, each one of these, are 2 coppers. So we have 2 coppers balancing each carbonate. And the question again is, what must each copper be so that together they balance out the -2? If you think about it, each copper must be +1. That gives you a +2, which balances out this -2. So the answer here is copper is +1, and carbonate is CO3 -2. Notice in both of these cases, you knew about the last one, the anion, the second one, and you used it to figure out the first one, the cation. And that is really what you would do in these. All right, so this completes for us lesson 2 of chapter 7. We'll practice many more in school.